Hello, Brian Rudkin from Carpaccio.cloud. Welcome to the web conference. I'd like to ask you a couple of questions about Carpaccio.cloud. First, can you explain a little bit about it and tell me how you're approaching the diagnostics and research sector?
Thank you very much. Very glad to be here. It's quite an impressive conference, I must say. Yes, Carpaccio.cloud is a software as a service, a solution to essentially disrupt analysis of microscopic images of muscle cross-sections, and this for neuromuscular disease at this time.
Now, we were talking a little bit about your kind of target market, which is relatively niche and focused, but maybe you can expand a little bit about the pipeline and how you approach this market of neuroscience. Yes?
Yes. Neuromuscular disease. In France, people are very familiar with the telethon. And we had Jerry Lewis in the United States, the March of Dimes as well, for studying neuromuscular diseases that are very crippling, but also aging, where you get muscle wasting, which is called sarcopenia, which is age-related loss of muscle mass. And also in cancer, one of the secondary results of cancer is the tumor is trying to get energy and it takes it from the muscles, and so you have cachexia, which is the loss of muscle as well. And athletes who hurt their nerves, a sciatic nerve, you can lose muscle mass as well. So the idea is to accelerate the research, facilitate the research to develop treatments and our understanding of muscle diseases. So the approach is to help the biotech companies, the research labs of course, but also the biotech companies and the contract research organizations who are working for the pharma companies to develop new treatments, to accelerate that research, both in the research labs for the understanding of the diseases and in the biotechs and CROs and pharmas in the treatment of those diseases.
And your process is both more, I'd say more efficient than the procedure that's generally done, which is in a lab with a human eye that needs to look through the muscle, identify the key spots. And your technology can do that twice as fast, 3 times as fast?
Actually 2,000 times faster than a human being. What normally happens for the analysis of muscle is you take the muscle and you cut a very thin slice perpendicular to the fibers. You put it onto a glass slide. You label the membrane, cytoplasm, and nucleus with different colors. You take a microscopic photograph of it, and you then quantify the size of each of the fibers by doing the perimeter of each fiber manually. Click, 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 click. So for one muscle, say the tibialis anterior, it's 3,000 fibers. It takes up to 2 days, sometimes 2.5 days, to do all these analyses. We do it in 30 seconds, and we give a full report on the data presented the way the scientists would want to have it. And that's 2,000 times faster than a human being.
And can you tell me what your plans for the future are? You're a relatively new company. You started in October. What are the next steps?
So right now is to secure our client base and to enhance our reputation for being 100% reproducible 24/7, accessible anywhere in the world through different types of surfaces, be it your smartphone, a tablet, or a desktop or laptop. And for the market development, it's essentially we're implementing technologies that are extracting the data and using the data for what we call deep learning to enhance the quality of the analysis on the one hand. And on the other hand, for each one of the fibers, we're extracting up to 70 different parameters that we are going to be analyzing, or we're in the process of analyzing, to try and correlate this with the physiological state of the muscle and act as a very trustworthy support for the pathologist doing diagnostics. And so that's where we'd like to go. And if I may finish, the idea is then to adapt this approach to other tissues that are similar to muscle, such as nerves or others, but even blood smears. This is a patented technology. The patent's issued in the EU, and essentially expand the market to the diagnostic area, digital pathology first.
Well, thank you very much.
Thank you.
Welcome to the web conference.
Thank you.